Right, here's a tricky looking standalone question. This is question 5 on page 300. I'll read it to you. I've drawn what's in the storyline anyway. It says the total area of the square and the rectangle is 64 centimetres squared. All these units are in centimetres. So I know that that area plus that area equals 64 centimetres squared. Is that alright? So I'm just setting up a little equation, and I'll get back to it as soon as I can. So I'm told that the width of the rectangle, that's y, so I'll write it down here, is 5 times the length of the square. Right, so y equals 5 times the length of the square minus 14. Right, there's a simple linear equation there. Of course, this is about quadratic equations, one linear equation, one quadratic equation being solved simultaneously. So let me read that again to you. It says the width of the rectangle, they give me it as y, is 5 times the side length of the square, in other words the x value, minus 14. There's a simple linear equation there. So I've got that one to deal with. Now what about this one? I'm told that the total area of the square and the rectangle comes to 64. Time to set up an equation. So x times x, x squared, square done. Y times 2x, 2xy, rectangle done. All comes to 64. So I've got that, and why don't I take this part of the equation for y equals 5x minus 14, make it stand out a little bit better, and I can plant it straight into here where the y is. And I've got just an equation with x's only, so that's the best route through. So I've got x squared plus 2x multiplied by 5x minus 14 comes to 64. Alrighty then, so multiply this out, make this look a bit more like minus 14. The trouble is it's lagging slightly, so it's getting quite tricky to do this thing. So multiplying out then, I've got x squared on its own, 2x squared times 5x, that's going to be 10x squared, and then 2x times minus 14 is going to be minus 28x's, all comes to 64. Alright, so tidy up a little bit. I've got 11x's, well rather 11x squared, and then minus 28x. Let's subtract the 64, bring it over to this side, and now that equals 0. I now have a quadratic equation with just x in it, and I've merged the two according to the storyline they've given me. Now a, b and c, the same thing again. Let's try and go for it. Not nice. So a is going to be 11, the b is going to be minus 28, and the c is going to be minus 64. It's definitely a mistake using red, I'm sure. I can't see it. Now I'm going to have to try and work it down here somewhere. Let's go for it. So we're solving for x then. So x equals minus b, which is minus 28, plus or minus the square root of b squared, and b squared is going to be minus 28 squared, minus 4, a is 11, and c is minus 64. There you go. Horrific. Divide all that by 2 lots of a, which is 2 lots of 11. I might have to use another page on this. Let's try and get one solution anyway. Or maybe just tidy this up a little bit and then just go over to the other page and finish it off. So, first thing, minus 28 is actually plus 28. And then give or take the square root of. Now I'm going to do this all in one step, alright? Hopefully it will stand out. Well, 2 steps. Let's just do 28 squared first and get that a little bit written down. So that bit comes to 784, and then I've got to do 4 times 11 times 64. Yeah, and of course it's a minus times a minus, it becomes a plus, and that's going to be plus 2816, and then divide all that by 22. Is that alright? So what I want to try and do now is actually highlight all this and maybe take it next door. It will let me do it. Yeah, if I take that next door and copy it, then we can carry on, can't we? Oops, do it again. Highlight all that, right mouse, copy it, turn over, and plant it somewhere. Paste. You shoved it down there. How about we move up here somewhere? There you go. Technology is wonderful. So there it is again. So that's what I've got so far. So now I've got loads of space to breathe. I've got 28 plus this part here, which is going to be 784 plus 2816. Press equals. Now the square root button on that, which is 60. Oh great, so the square root of that was 60, and divide that by 22, and that's going to give me plus 28 equals, divide that by 22. I've got an answer of exactly 4 centimetres, so x is exactly 4 centimetres. Let's just do the other one by saying and 28 minus 60 divided by 22. Remember, all this part here came to 60 as it turns out. This comes to 3,600. Of course, the square root of 36 is 6, hence minus 60, or 60 as the calculation there says. So let's just do that quickly. I've got 28 take away 60 comes to 32 minus 32. Divide it by 22, and that's going to give me minus 1.45. Minus 1.45 centimeters. Well, listen, you should recall now, since we're playing with actual physical lengths here, this length cannot be minus anything, can't have negative lengths. So I'm now going to write in this bracket here, ignore, just to show the examiner I'm not using that solution at all. Now, had it been another positive solution, all right, I've got to use them both and get lots of answers. So the only valid solution is x is 4. So read my question. It says, find the dimensions of the square and the rectangle. Okay then, so let's just do the rectangle. We've got to work out the y dimension now, and we use y equals 5x minus 14. So turn over. Y equals, is it 5x, was it? Right, y equals 5x minus 14, yeah, just got stuck there. Y equals 5x minus 14, so that's going to be 5 lots of 4. Oh dear, minus 14. 5 fours are 20, take away 14, make that look like a y, and that's going to give me 6 centimetres. Right, so what have I got? I've got the square, which is going to be 4 by 4, and the rectangle, which is going to be y is 6, isn't it? Just check. Yeah, y is 6, and the length will be 2 lots of 4. Well, it's not turning over. Right, got it. So that's 2x, so it would be 2 lots of 4, which is going to be 8. So the dimensions are 4 centimetres by 4 centimetres for the square, and the rectangle is going to be 6 centimetres by 8 centimetres. And I'll stop the video. That's really glitchy. I'm sorry, it's not going to be very nice to look at, but and I had to stop and start and throw the pen around the room as well. Sorry. I'm going to leave it like that. That's your answers, and that's the end of question 5. Right, really fancy do question 6. It looks challenging. It's nice. Right then, it says the diagram shows 2 squares, and I've drawn them. If it's a square, then it's an x by x square. That shouldn't have happened anyway. It's an x by x square, so that's what that is. And I've got a y times y square. It's a proper square. So they're shown, and one's inside each other. Obviously, you've got a little one inside a big one. The area of the shaded part is 36 centimetres square. So all of this, I'll shade out in blue, although the book says it's all yellow. So all this comes to 36 centimetres square. In other words, the area of the big square minus the area of the little square equals 36. Straight away I've got an equation. Look at that. So y squared, the big one, take out x squared, the little one, gives me some random space around the edge called 36 centimetres squares. And all these units are in centimetres. That's why I've given you that in the corner there. So that's an equation. Now here's the next bit. The difference between the side lengths of the squares is 2 centimetres. In other words, the difference between the lengths of the sides is only 2. Well, y is the biggest one, isn't it? So if I take y, that's like saying that's the same as x add 2, isn't it? Or I could say y take away 2 equals the x. Is that alright? So x, the smaller one, add on 2, gives me the equivalent width or side length of y. There's my two equations. I've got to somehow do something with that to work out the length of each square. So in other words, I'm going to get an answer for x and an answer of y. Now there could be two valid answers for each one, or there could be a negative answer which we ignore. But what I'm going to do now is take this x minus 2 and substitute it in there, alright? So I've got an equation with just x in it. So what I've got is y squared, which means x plus 2 squared, then take away x squared, that comes to 36. Multiply this out, gives me x squared plus 2x plus 2x plus 4x, therefore, plus 4, 2 2s are 4, and then minus x squared comes to 36. My goodness, look at this, x squared minus x squared. So what I've got is shocking, not even quadratic. I've got 4x plus 4 is 36. Take the 4 over and minus it, so 4x comes to 32. Therefore x equals 8. 32 by 4 is 8 centimeters. Look, there's only one solution. I've just got it. That's it. That's your lot. So x is 8, and therefore y is going to be 8 plus 2. There it is, x plus 2, and therefore that's going to be 10 centimeters. Now, although this looks horrific, there was nothing to it whatsoever. You know, even equations with x squareds and y squareds, it simply wasn't there. It didn't form a quadratic. It formed a straightforward equation where the x squareds cancelled, and that's your solution. That, I'm afraid, is a very, very peasy question 6. Let's just check I got it right, 'cause it's just too easy. The side length of the small square is 8 centimeters. The side length of the large square is 10 centimeters. I got it right. So now I'm going to reward myself with a very large cup of tea and maybe a huge chunk of cake, or you know, probably a packet of fig roll biscuits would be nice. So that's it for now. Boringly easy, sorry, not very challenging, but there you go. If you get one of these in the exam, it turns out being this easy, think, yippee, I've got it, I'm going to get a grade A for that, for doing nothing. Right, see you later in the final section of these simultaneous equations.